who is already climbing everything he can. Welcome back to the stream, folks. Oh man, this cat is amazing. Let's go ahead and get this on cat camera. That opening title card never stood a chance with the cat being this cute. Careful with that C-clamp, dude. Tuco found my test setup here, but it doubles as a cat perch. Alright, I really owe this cat a lot of games of Bolt, so that's how this is going to start. Try to talk at the microphone. I might wear the headset depending on how bad this is. Good job, boy. I'm gonna enjoy my tea. So hopefully you can hear some of this. I'll try to maybe speak up and speak toward the microphone. So there's been a bit of gap in the streams. I've been a little depressed for the past week, so maybe that's been part of it. I haven't been wanting to be as social in the sort of way that I can handle being social online. But I've also just been busy editing, and so some of you might have seen that I released a couple of new edited videos lately. I made a little short one with footage of Tuco introducing the project where we're building a little robot to hang out with him. And that one's only like 5 minutes, so it's a good way to get an introduction to the project, and it has a lot of cute cat footage. And then just yesterday, I released a new kind of longer edited episode on the mechanical and electrical modifications to the camera gimbal. So that was really nice, but I still have a lot of footage to edit. I still already have, I think, everything I need for another episode about the firmware modifications and reverse engineering on the gimbal. So I've already started editing that, and I could just keep hermiting out in my editing hole and editing that, but I think, in the interest of trying to get some balance, it'd be nice to try to, interleave the editing in the streams a bit more, And yeah, so I'd been partially avoiding the streams because I'd been diverting my energy toward editing, and and partly just didn't really have the social energy. But then partly it felt like the stuff that I needed to do next wouldn't be super interesting. And I hadn't really gotten to a point that I was really excited to share, so there was that. But I'm going to try to share what I'm doing anyway, even if I don't necessarily think it's like the most exciting development work, because I think there is still some stuff to talk about after talking a little bit over this between streams with some of the folks in chat. It seemed like maybe some of the stuff that I had been some of the design decisions that I'd been getting a little bit stuck in that to me didn't really feel like making progress might be stuff that would be worth discussing. I'm going to bring maybe a little screen of some sort over here. Where does Tuco anyway? Let me see if I can figure out where he went. I'm also realizing I can't really see chat. I'm a little too far away from the monitor. Tuka, you're so quiet. How are you so quiet sometimes? You still want to play? What were you doing? Were you trying to find a really hard one? I guess I wasn't paying attention, and he probably was trying to find one that got stuck somewhere behind the stairs. Hey, Duke, I know where there's more bolts. Did you catch that one, too? It went right over here. Oh, nice. Just noticed from in the chat. I think I saw the picture Emily posted. I think they're talking about nanoleaf LEDs. Pretty cool picture. I didn't see the teardown. I'll have to check that out. Tuco has pretty interesting paws, yeah. He's got a thumb. He's also got an extra claw in between his thumb and the rest of his fingers. So he's got lots of places to be sharp. He's quite good at being sharp. Where's the bolt, Duke? Here it is. Was that a bad throw? Nice. Good job, Duke. Good job. Good boy. Nice catch. Good job, boy. Uh-huh. Just catching up on chat. Yeah, I appreciate the compliments. Thanks. It's always fun to, find interesting new ways of making technology do stuff. And, it seems to be interesting in its own right, but I also like how it kind of prompts people to think about technology in new ways. I think that's a lot of what's kept me going at it. Hey, Duke. You in cleaning mode, or are you in a play still? job, Tuke. Was that not the direction you wanted it to go in? What was unsatisfying about that? Where did that go? There it is. Oh, there's a bolt under my shoe. Is this what you wanted? Good catch. It went right by you. Got that one too. Me too. Are you done with that game to go? Are you done with that? Alright, well, maybe my cat's finally getting tired. Well, I guess if my cat is tired of fetching, we can go to plan B and actually talk about electronics or work on something. Oh, so I was curious what you meant. So XRNand in chat, Andrew was asking about a TI chip. Was that in relation to like the PLC glitching or the stuff on my desk? I happen to be using the same chip for both. I was using it before because it happened to be. Let me reposition the camera. So I was using that TI chip before because it happened to be in this Siemens PLC device. So I got some of the dev kits to experiment with the chip on its own. But now I'm using it because it happens that when I look for a microcontroller that has the peripherals I need, including Ethernet, and just sort them by like general price and feature set and things like that, then this TI dev kit actually turned out to look like a pretty good deal. So that's what I've been trying to use as a basis for this robot lately. Oh, so yeah, for the gimbal, I'm planning on using, so the gimbal itself has an STM32 in it, and I think, assuming I don't find anything better, I'll probably just use a bunch of these TI dev boards for each of the winch controllers and for the flying part of the robot, since it seems to be a pretty easy and low-cost way of making something that just takes, UDP or TCP or whatever I want, and has some motor controllers and timers and stuff. Hey, Tuco. Are you ever going to be in frame? Are you looking for a bolt now? just want to watch me play? I don't know what you want, Tuco. Oh, back to our regularly scheduled not knowing what the cat wants, which I think is fine. So, yeah, so you might have heard me rambling earlier about these TI microcontrollers. So that's what the current bout of yak shaving is about. And I mean, this is one of those kind of classic engineering problems where there are fairly few constraints, but the constraints that I do have make it kind of annoying to use the really easy solutions. So like, I don't know, I imagine if you were to just think, well, what are the absolute easiest ways that I could build these things? Probably would be for the Flyer, maybe a Raspberry Pi. For the winch bots, maybe like an Arduino with an Ethernet shield. But there's stuff that I don't like about each of those solutions. You know, having a Raspberry Pi on the Flyer, I would still need another microcontroller on there to handle all the interfacing, and then I would have to have a protocol between that and the Raspberry. And at that point, I don't actually know if that would be simpler. Like, I think it might just be easier to have one micro that has a really simple Ethernet interface with maybe UDP packets that give it commands, and then it could just have a higher priority interrupt doing whatever motor control and sensor measurement I want, and it could have its watchdog timer enabled so that I have some measure of safety against the microcontroller hanging. Well, so I don't think the weight. So Andrew in chat is saying that maybe it would be really heavy. I don't know that would be a problem. I'm not talking about making this a quadcopter. I mean, it's now on cords, and I think the weight difference between like this dev board and a Raspberry Pi is probably pretty negligible. And I wouldn't have to worry about the difference in power because the power is all coming in externally. Tuco, do you want to play again? Do you just bring me a bolt like right after I stopped? He's not even on camera or fetching. What a confusing little beast. So the things I find appealing about this entire board is $20 from DigiKey, so the whole package is pretty easy to get started with. Like, it's cheaper than a lot of Arduinos. And it has 100 base T Ethernet. It has, you know, the software I'm not happy with, but I'm trying to find like the least annoying way to work with it, and that's currently one of the yaks to shave. It has all the peripherals I would need built in, though. It has, you know, timers, PWM outputs, plenty of GPIOs, serial ports. And it's mostly just one of those things where I just find that most of the time when a silicon vendor makes a tool chain for their microcontroller, it just completely rubs me the wrong way, and I just want to redo everything. You know, I'm the kind of person where I really hate being forced to use like a specific proprietary compiler. I'd much rather have something I can just use GCC or LLVM or something standard with. So especially if it's an ARM chip and they want me to use a proprietary compiler, I'm really tempted to try to find a way around this. And so I have used their, I think TI calls their dev kit the Code Composer Studio, CCS. So I've used it a little bit because when I was doing glitching on this same processor earlier, I was trying to make a binary that was probably very similar to what some commercial software was going to look like that would be using that compiler and dev kit also. So I've used that a little bit, but you know, it has all the usual problems I don't like about proprietary compilers, where it's just like very lock-in with that specific set of tools, and you can't just kind of like bring your favorite tools. So then with this chip, there's actually a project on GitHub where they've taken the kind of TI examples and library headers and everything else that you would need to develop with this, and kind of wrapped enough of a build system around that so you can just use GCC and make files with this, using TI's libraries still, but at least using an open source toolchain to build the thing, which makes it, in my opinion, much more tolerable to deal with. And so you can program it using this USB interface. You could just use OpenOCD if you hook something else up to this JTAG. So that's been my plan so far, is to use this open source Tiva-C project on GitHub as the basis. And then on top of that, I have a bunch of options. You can pretty much choose to to go as low level as you want. But there are a couple of particular levels of implementation that they've made easy with their set of libraries. And so one of those is if I want to use the LWIP stack, then there's kind of this glue layer that handles all the DMA buffer allocations and is basically like a Ethernet driver for LWIP for their onboard Ethernet controller. And so if I can use that, that would save me some code re-implementation. But especially given that I care a lot about reliability and the networking features I need are extremely basic, like I could probably just deal with raw Ethernet frames if I needed to, then it's also tempting to just throw off as many of those layers as I can and just deal with handling the Ethernet frames and the DMA buffers myself. Oh, John says, why is that Ethernet cable so thin? This is a pack of especially thin ones I got from Monoprice recently. I just got them, so I don't really have much of an opinion about them yet, but they seem pretty nice, and they were cheap. They're like patch cord, so they're not very long, but they seemed useful for this especially. And I got them in different colors, so I could color code all the robotic ones because these are on a separate network. Yeah, so ESP8266 would also be maybe something to look into for a project like this, except with at least the original ESP8266, I don't think it had a lot in terms of wired networking options, so that wouldn't be super useful. And it wasn't an AVR core, it was, I'm forgetting the name of it, it was a less common 32-bit core, but there's still like a GCC port for it, so it's pretty easy to use. The ESP32, most people use it with Wi-Fi. You can connect it to Ethernet. It just requires a lot of I/O pins. And let's see. So Joseph is asking, are you using CCS or Energia or? And so I've used both of those. My plan is to not use either of these for this upcoming project. I want to use this thing that lets me just build using GCC. Where did I put the computer here? Let's save this for later. Oh geez, here's my mouse. Let's see. Yeah, this is what I plan to use. I think I like this much better than any of TI's offerings. This is basically just a way to use plain old makefiles and GCC to build for this board. And the thing that I like about this is it makes your project very hacker friendly and very portable. Like you can take the same code and use it on other ARM machines really easily. You can build this just using standard ARM GCC port. So I think I like this. I mean, it still bothers me that TI has this kind of annoying license on their board or on their example code and their libraries, which is sort of weird. So a lot of silicon vendors basically end up designing these toolkits that aren't well thought out enough to give you a natural clean boundary between your code and their code. And then so that on its own is kind of annoying, but wouldn't be a huge problem. But then combined with the fact that the lawyers and the silicon vendors often put these weird licenses on their code that often makes it legally dubious to use that stuff along with significant open source projects, that often is why I really don't like the silicon vendor code. What's up with this library? See, this is not too bad, I think. This looks like it's got an advertising clause, but otherwise it seems like this is pretty open source compatible. And this is their peripheral library. But, and And so maybe that's part of what this open source project did, is it like took the stuff that was pretty open source compatible and like not the stuff that wasn't. But a lot of the TI code has stuff in their licenses that says like you can only use this with TI products, which on its own is kind of annoying. But then they go a step further, and there are some licenses that say specifically you may not combine this with code licensed under any open source license, and that's just a non-starter. So it's like, if you just want to like kind of barrel ahead by copying and pasting stuff out of the examples, you can do it, but it can end up with your code existing in this kind of legal gray area. So since I like to build durable open source projects most of the time, I like to find a way that my code doesn't end up kind of as a side effect of sloppy engineering and legalese end up encumbered by the silicon vendors' licenses when it's just stuff that I wrote, you know? So as a consequence of that, like, this is one of the things that appealed to me, since you can pretty easily just build your code using standard tools and just like have this as a separate repo checkout and just grab the files you need from it. I'll look at this briefly just since it's here. So this is just kind of a cartoon mock-up of something I've been thinking about for the actual flying part of the robot. I've mostly just been thinking about like grossly where to put things, where the center of mass might want to end up, what the sensor arrangement's going to look like. I'd been really kind of stuck on the idea of using a depth camera. Since Kyle was nice enough to donate a depth camera, and I thought it would be really nice to use that for obstacle avoidance. But I think for a couple of reasons I might avoid using that. I've spent a lot of time just yak shaving and trying to get it working, and so far haven't actually been able to get the device working at all. And so it might just be bad hardware, or it might be something I'm doing wrong, but I've tried several different ways of operating it with several different computers at this point. But the other issue with the depth camera is that I don't think... So all of these optical devices that are going to be measuring distance tend to have a minimum distance, just based on, you know, something's too close to the lens, you're not going to be able to focus on it, or the lights, you know, like, it's going to be occluded before it can actually bounce back to the receiver in this case. So the depth camera had a minimum distance of, you know, rated at something like, I think, 0.5 meters. And I think in many cases it would see stuff closer, but that ended up being kind of suboptimal. These, what is this distance? I'm forgetting off the top of my head, but I made these little indicators to show what the sensitive region would be. So I'm just going to use the Fusion 360 measurement tool. I think I can measure from that face to like there. Minimum distance, 98 millimeters. Yeah, I think this was the like 10 centimeter to 80 centimeter rated optical. So these are infrared distance sensors. They're the really kind of old school, ubiquitous analog sensors made by Sharp that you'll see in a lot of robotics projects. And so in this mock-up, I decided to try, so I found a good deal on this particular one, which has the 10 to 80 centimeter range, I think. And so I tried just modeling a bunch of these in a ring, so 8 of them specifically. So this would be what it uses to detect, you know, if it's about to, you know, settle down onto something. It could be short-range detection for a floor under here. It would detect obstacles it's about to bump into going sideways. And this is just a mock-up for the envelope that the gimbal would occupy. So I've been thinking about how this would work. The cords, I think, would attach up here, probably such that the nylon cords actually go all the way to the center and then attach around maybe a washer. And then I'm not quite sure what the vertical structure would be, whether that's just all 3D printed pieces or whether it makes sense to have like maybe a carbon rod or something like that. I've also been thinking about, so one potential benefit of putting a Raspberry Pi on here instead of the microcontroller would be that it could be easier to add just random add-ons, like we want to put some, doodad that drops objects on the ground or like projects lasers or something. But adding random peripherals to this, like, I don't know that that's going to be super easy to do at this mechanical scale, since, if you imagine just making perhaps a modular system where you can just bolt stuff on to the sides here, you would still have trouble with, if that was interacting with the outside world at all, then it would start to cross these beams and cause false triggering. It would easily disrupt the center of gravity, and it's just hard for me to imagine stuff that I would want to put on such a small robot that's so sensitive to center of gravity. So I don't know, I'm starting to think that whatever expansion we want to do on this project, like additional projectors or launchers or whatever, they might not even really want to be on this device. It might just make more sense to have those situated elsewhere in the environment. So I have like a railing up high that things could go on. I could put bolt launchers kind of down on the floor where Tuco likes to interact with stuff anyway. And so here are my main concerns. So I need the microcontroller to act as a bridge between the gimbal controller and the Ethernet that's going out over the umbilical. That's the kind of most immediate job I need a controller on here for. But I also need something that can measure the LiDAR pulses. So the LiDAR sensor gives me pulse width modulation, and I need to time those pulses and send them back over the Ethernet. I'll also need, assuming I'm going with these analog distance sensors, I'll need an A to D converter to measure those. I'll probably want an IMU on here just so that I get another reference for the angle and acceleration of this whole platform. Since I can't interact with the IMU on the gimbal like super directly, I can just get kind of completely baked angles out of it, and it'd be nice to have an accelerometer as well. Hey Tuco, I heard a bolt. Here it is. And then I might want additional positioning sensors. So the most obvious upgrade I can think of, so something that I might want to add later but not immediately, would be receivers for the HTC Vive Lighthouse positioning sensors. That's something that I don't really want to like hold up this whole project on, but I would want to add later. And for that, I have to imagine that that would end up being a bit of a mechanical redesign anyway, to add sensors all over the place. Or maybe there's a way that I can, place a lighthouse like up above where this robot would usually be, and then place a bunch of sensors on this top panel. So I can imagine some ways that I could do that, but it doesn't seem like something where if I just have like a single like modules go here kind of plug-in location, or a few of those, that's going to be something I can use at all for something like a Vive tracker. Oh, geez. Mark just donated $25 via Super Chat. Amazing. Well, thanks so much. I just figured out, I saw, I'd ignored it when they first started prompting me to enable it, since it just seemed like another kind of YouTube revenue stream that I didn't want to enable, but I don't know, seeing it in action on Adafruit's chat kind of helped me turn to the other side, and I turned it on. So I'll let you all know how much of that comes back to me. I don't really know what the ratio is like yet. So the nice thing about this controller is, besides the Ethernet, it's also got just like all the onboard peripherals I would need. So I can measure the LiDAR accurately with this. It has A to D. On the kind of other half of this, on the winch bots, where it would be convenient to have some overlap in the designs if I can. So using the same controller on the winch bots, that has the advantage of a nice pulse width modulation controller, so I can do the motor speed control. It also has, I think, some hardware that can read quadrature encoders, which will help with reading the distance traveled in the winch bot. So my inclination right now is to not really worry too much about designing this with explicit expansion, since I figure if I can just generally make this case modular so that I don't make any of the individual pieces super large, and then later on when I want to add stuff to it, I can like replace individual pieces as it makes sense to. And then, this board already has plenty of headers where I can add stuff, so I think I'm covered as far as expansion, and I can just add more code to this micro when I need to. Oh yeah, Charles says the Vive tracker would fit nicely as a hat on this. Yeah, well, I think it would need to... Yeah, I think it depends on where I have the transmitters, first of all, like... Because this has a lot of vertical travel, like this is going to be up and down in the room. And so if this is moving around, and then I can always have the Vive transmitters above it pointed down, then I can imagine, let's say the chords come in at a variable angle. So that they could be maybe shallow, maybe relatively steep when it's near one edge of the room. Which probably means I have to have the lighthouse sensors under the chords and just deal with a little bit of occlusion, which is probably fine. So the chords would still attach near the top to kind of a pancake structure. And then that means the Vive sensors would probably have to be just on the top side of this board, kind of opposite the downward-facing IR transceivers. The other option is have the lighthouse kind of more at working level. And this is maybe, if you'd imagine like this is kind of the area of the shop where like people and cats hang out, and like this is the above space where it's mostly empty air. I could have the Vive transmitters are down here right now because that's where it makes sense to use them for VR. Having a transmitter up there would not actually be super useful for VR because it probably wouldn't reach down there. It might even just interfere. So if I wanted this to be compatible with Vive VR, then it would be nice if the receivers could be more on the sides, but then they would need to be all over the sides probably. And I think the way I'll probably do that is, I'm still thinking about the structure of this, but maybe the top of this comes in kind of like a pancake that holds the sensors. So it's flat on the top, has printed structure on the bottom that the sensors fit into. Then there's some structural member that goes vertically through this whole thing, like a cylinder or maybe a carbon rod or something. Then on the top, there's a support member that's maybe like a washer that clamps onto that rod somehow, and all the cords attach. And then there's like a 3D printed piece that holds the cords at the right angle so that you can kind of so they don't like slide around. And down here, I could imagine this being some flat 3D printed support members, or just maybe a rod with some braces that hold the board. And then I could imagine kind of a two-piece shell that goes over that. And then I could imagine having a new version of that shell that I reprint that includes IR receivers for the lighthouse later on. I'm not totally sure how to anchor to this piece either. There are also some screw holes that I haven't modeled yet, so I could use some of those screw holes. Normally what it would do is there'd be another piece very similar to this one that it would attach to using kind of rubber balls that act as shock absorbers. I don't think I want those in this case. I think the nylon cords have enough compliance for this whole system, and I'd rather just have this be rigid. So in that case, I could potentially just use these to hold plastic posts and then have little like retaining washers over that. Oh, Tuco found another bolt. Where'd you put it, Tuke? Where is it, little guy? I don't see it because I'm not as good at this as you are. I see the T though. Did you just fish that bolt out and then lose it? Or am I just not seeing it, Duke? Oh yeah, so Charles in chat says, I'm trying to learn Fusion 360 at the moment, but not getting the hang of designing to make it easy to modify later, ends up in a tangled mess. I had the same problem. I think I'm just starting to get over that hump and had to make many mistakes and learn from them before figuring out how to design stuff that is less of a mess once I've worked on it for a week or so. I think, yeah, some of the good advice I've gotten, at first it felt really, really unintuitive to use joints and components, and to some extent it still does because they're just so unused to how I think that they should work. But once I finally got my head around how Fusion 360 thinks they're supposed to work, that's been helping a lot. And also just generally trying to keep an eye on how messy the timeline is getting and try to look for ways to avoid that and try to keep the number of cross dependencies low. But it's a lot to think of, and I still find that a lot of what I'm doing in designing is kind of making messes as I figure out how things should work and then cleaning them up as I figure out how I should represent them. Whoa, another super chat from Vince. Thank you much. Oh, and a question from, I can't quite read the name, GA Starbiter, I think, who says, did she say if she's going to decode the SDI on the Raspberry Pi? Definitely not. My goal with the SDI was to send it down into this equipment rack, which it'll have a machine with a Blackmagic card and a decent GPU in it. So it'll be doing the H.264 encoding and overlays and stuff for the stream. Plus, I'll also probably be doing some computer vision on there in real time. At the very least, I want to do optical flow tracking so that I can have the gimbal track points on the screen rather than just giving it like low-level left-right commands. Hey, Tuke, where is it? Oh, here it is. I might have to go back over there and play fetch with him for reals. I mean, really, this is what I would love doing on a Sunday pretty much any time, is just playing fetch with my cat and drinking tea. Hey, Tuke, you want this one? Oh, All Scout on chat says that Tuco's chubby. Yeah, he's been getting a little chubby. I've been trying to figure out how to get him to eat less without just complaining about the food all the time. I think I need to get him a new mix of foods. Make sure to have him chase stuff a lot more. Hey, Tuco, where did you just put that? Oh, there it is. Just a bit of computer vision. Yeah, there's a lot that would be difficult and super time consuming. There's also some really easy stuff, like you know, I've done sparse optical flow tracking on several projects, and I think something like that would be pretty easy. I mean, with the GPU, you could do dense optical flow too, but I think I'd rather save the GPU power for video compression. Like, I can imagine a chat interface where there's kind of a little focal point indicator or something, and you can move that around using commands. Like, maybe there'd be commands that just make it jump around, maybe there's commands that make it search for something, and then that would be what the gimbal actually tracks. Oh, a question from John, who asks, any particular reason to place the IR sensors above the cam? Seems they need to clear the camera / gimbal anyways. Do you mean just like placing them above the camera in general, or placing them so far above the camera? I'm aiming them so that they kind of form like a little cylindrical cage around the camera for detecting obstacles. I can go back to the CAD in just a sec. Was that not what you wanted, Tuke? Yeah, really, we gotta get some of these bolt launching bots going and the camera as part of an exercise program for Tuco. Aw. Good job, boy. Another go. All right, so yeah, the gimbal is down here. The camera could point anywhere from a little above this to, mostly all the way down. So the idea with this is that I wanted to protect against obstacles that you might bump into if this is moving sideways or down. So if you're moving sideways, imagine there's like a person over here where my mouse is. If you bump into this, then now one of these distance sensors will see that object before it crashes into the gimbal, hopefully. That went right by you. I mean, it went under these cables. You're just watching me play with it now, aren't you? Chico, this is not how the game is supposed to work. I'm going to let you figure out that one. Oh, and John says, I was expecting maybe for the sensors to be on the sides of the camera. On the sides. So part of the problem is they're just, like down here, I mean, a lot of these are just like guides, which I don't have an easy way of turning them all off right now, but like the actual extent of the robot would be from right up here to down here. The gimbal would be the lowest part. And so the gimbal would be basically like if you dropped the robot, it would just land on the gimbal. So there isn't really a place to mount any sensors pointing sideways, and making a place to mount those would involve obstructing the gimbal's view. So the idea with pointing the sensors up here was that I could have the sensitive regions all be down here while keeping the sensors themselves out of the way. And then the reason they have to be so far up here is because I wanted the unusable part of the range here to be well out of where I thought the obstacles would end up needing to be detected. Hey Tuco, you want to play again? Did you change your mind? Did you find it? Are you still looking for it? Good job, Chico. Help, do you see it? see an end to their cheek? Oh, is that it? Oh, did you just get it? Are you looking for more bolts now? Good job. No dice? Was that one just too much work? Oh, here's two different kinds of bolts too. We have transparent PLA and nylon. Have we finally tired out this cat again? We may have tired out the cat again. Oh, Fedora is asking if the gimbal assembly is already operational. Yeah, Mark beat me to it, but yeah, mostly. Yeah, it needs maybe a little bit of tuning that I've been putting off. There's a tiny bit of wobble in the yaw axis that I think I just need to calibrate out. But yeah, it's basically working, so I've been focusing on other parts so far, and I've also gotten enough footage at this point that I've been trying to edit those together into videos. So I've got one out with just the mechanical stuff, and I've got another one in progress with the software and reverse engineering stuff. So yeah, still thinking about this, but I think maybe the next step is to work on the firmware a little bit. I'm also still not sure whether to put another LiDAR sensor on the body of this thing. Since it seems nice to maybe have a sensor pointing at the ceiling, for example, or at the floor, or at one wall, but without that sensor on another stabilization gimbal, I don't know if that's going to work out well. I guess the floor-mounted sensor, I guess I could just have them be gravity leveling, basically, like have the LiDAR be on a little tiny, I keep wanting to call it a plumbus, which isn't a real thing, a plumb bob. Like a gimbal that has a heavy end that points down, and then the LiDAR end is on the opposite side. I mean, that would wobble a whole bunch. Yeah, so, I mean, I don't know if that sensor is even super useful. Since I'm not as interested in absolute position on here, I'm mostly interested in relatively positioning this around things that I can detect in the camera's field of view. The absolute positioning that I do care about, that's going to involve like making sure the robot doesn't break itself, maybe having keep out zones if I want, regions that the robot's allowed in and regions that it isn't. But those things can be, they don't have to be that accurate. They can be done pretty conservatively. And so one thing that another LiDAR sensor on here might help with is, am I getting close to a wall? Am I getting, not like an obstacle, but like one of the edges of the volume that this can move around in. But that's also something that I can sense, like if it's getting close enough to one side that all the weight's being carried on one side, then I'm going to get out of the range of acceptable tensions on the cables on the other side. So I think that actually might be what the cable tension sensors might end up being super useful for, is effectively acting as soft end stops. so that I can move this thing around without too much regard for absolute position, but if it's getting close to one of the edges, I'll notice because of the cable tension. I mean, one alternative to that is absolute positioning, so just building in something like Lighthouse from the get-go. But I don't think that's really necessary. Another alternative is to have sensors that I can use to measure how close this is to the walls or the ceiling. So that might be like a rotating LiDAR that aims out horizontally in a plane. The trouble with that is that plane is going to tilt all over the place as this thing moves. I could have a LiDAR pointing directly up or directly down to try to get some idea of how tall this thing is, or how high it is above the ground. But neither the ground nor the ceiling are just planes, so I'd also have to account for that. So if I can avoid the need for a sensor like that, that sounds like a better option than having something like a single LiDAR pointing up or down, since I don't think I'd get the data that I want out of that. The sensors here would be obstacle avoidance and focusing distance. Do you want to play again, Tuco? I don't know if that's what he wanted. All right. Let's think about firmware, maybe. Are you gonna stand on the keyboards next, Tuco? Any of these USB devices working? That's better. Oh, not right now. And it looks like there's some kind of interlacing problem happening up there. Uh-oh. I had deinterlacing enabled on a progressive signal, it looks like. That's much better. I figured it would know that the signal was progressive and not do that, but I guess not necessarily. Today I learned. Okay. So this is that Tiva-C kit that we were looking at on GitHub just a bit ago. It has a bunch of examples sorted by what board they run on. So this is the 1294XL. So there's some stuff for the UART, for USB. The ones we're mostly interested in are these Ethernet examples. So let's just try Ethernet I/O first. I think I might have compiled this already, so let's get a clean build. So we're building this with GCC on macOS. I think this AXF file is just an ELF. Yeah. So this is actually the ELF binary. I don't know why the extension is AXF. And then this is the flat binary that you can burn onto Flash. And so this is the dev board. as I was mentioning earlier, these are nice because they're cheap, they have Ethernet, and they have a lot of other onboard peripherals that will help us in our quest. And so I've got the USB here plugged into the debug port, which is actually another TI TM4C microcontroller. But this one is acting as a USB UART and debug interface. So it implements this ICDI, I think is their protocol. So that's how we're powering it and communicating with it right now. And because of that, we can also open a mini-com with that virtual serial port. Do we have tty.usb modem? And throwaway password. I want this to be 115, 8N1, no flow control. So this should be our debug serial port on the board. Oops. And let's see if we can flash this Ethernet example. Let's also take a look at our network interfaces, since I think we should have an Ethernet interface on this machine that's connected to the board. Yeah, this USB 10100 LAN adapter is connected to the board, so I think they're just both going to get self-assigned IPs, and we can change that if we need to. My plan for addressing, so as I've said, I don't really care that much about higher level Ethernet protocols. I'm using Ethernet as basically a glorified motor control RS485 network here. So just sending around raw Ethernet frames might be enough, but at this point, I'm just trying to find a good balance between convenience and simplicity / reliability for the system. So maybe that means raw Ethernet frames, maybe it means UDP with fixed IP addresses, I don't know. So we can flash this example using LM4 flash, which talks to that in-circuit debug chip. And the build outputs are all labeled according to what compiler they were done by, so this is always going to be GCC. That should take a sec to flash, then we should get some boot up messages. Usually I don't remember it taking this long. Let's try power cycling that. Oh, maybe I just was not quite patient enough. I mean, one option is just to design the lighthouse sensors into this from the start, but that seems like a lot of additional work that I don't really want to have this all held up on. Okay. So I don't know what's going on with my serial port there. So I was having this same problem before off camera in some code that I wrote, and so it's actually interesting to see this in an example too. I don't know whether this is a problem with the debug interface or the serial port on the microcontroller, but it seems to be losing a bunch of characters. Let's see if there's a simpler serial example. UR echo. well. Okay. Well, I guess let's get the... I have to solder some headers onto this so I can get the serial port, and then I want the serial port on a logic analyzer. Unless the serial port's already on one of these exposed headers. I guess we could check the board documentation real quick to see if the serial port's already on one of these headers. Should have this file handy anyway. Good old SPMU 365. Yeah, this is the interface we were just using. So they give you a little, like, this is the most terrible way of splitting off the debug interface. So this header that they have labeled X1, one side of that goes to the JTAG on the main processor. The other side of this goes to the JTAG and, well, and serial on the built-in debug interface. But then to separate those, you have to take out all these 0 ohm resistors, which is kind of weird. Pin out. Is this the UART I'm looking for? It's UART 7. There are a lot of UARTs on this board. UART 0 control signals. I think the signal I'm going to be looking for is probably U0TX and U0RX. A2? In 74 and 76, is this what I want? Those don't have headers either. Is that A? So that's A2? A2, 5, and 6. Oh, there's a bunch of labeling on the back of this board. That's kind of handy. So these are all the ones that are easy to access, and so they have them labeled out. Oh, these are also all labeled. That's really nice. So the signal we're looking for is, I think, on port A. Yeah, PA0, PA1. The first two I/O pins are the debug serial port, I think. I guess it would make sense for them not to include it on these little peripheral plug-in headers since they're kind of weird. Alright, I'll just see if I can wedge some headers in here and get a signal. Oh, Tuco's on the rack again. Good cat. Let's use this camera. Alright, fine. I'm just going to solder some headers onto this. That seems like the easiest thing to do at this point. Beep, beep, beep. Yeah, this board definitely outpaces all the other solutions I know for just like cheap Ethernet. Like, it's really hard for any of the Arduino stuff to compete with a $20 dev board that has all the Ethernet stuff built in. And I mean, I could have used a different network, like maybe CAN bus, but I mean, I like working with Ethernet cabling and tools and stuff in general, so this was pretty nice. That looks pointed a little, not the way I want it to be. So one annoyance so far with the TI examples, it's really heavily biased towards using LWIP. So basically there are a couple of different routes that you have in terms of accessing hardware. You can go directly to the hardware, just accessing registers. It's the lowest level. You can go up one more level and then access it through kind of an API that they've built, just a bunch of C functions that wrap the hardware, which sounds kind of annoying. Probably is, but is also slightly convenient because that's what they've built everything around. This chip also has the weird property of having those wrapper functions also burned into a ROM. So you can choose to compile them yourself because they have source provided, but you can also use a version of those wrappers that are already burned into ROM. So it's kind of nice if those help make your binary smaller. I don't know, but a lot of them just replace like very simple register manipulation, so I'm not really sure if it was a great design decision. It's just kind of weird. All right. So James says, I'd thought if you needed absolute positioning, it'd be far easier to have an encoder on each cable reel and a big bit of trig, rather than a lighthouse. That's assuming you have completely rigid cable, which I didn't want in this design. I actually kind of wanted some compliance, so that, you know, I think it would help dampen vibration and also prevent things from getting damaged quite so easily if anything does get hit or tangled in the cables. So actually having some cable that has a little bit of stretch to it and then being able to measure that stretch That's the solution I ended up wanting to go with. And as far as absolute positioning, like, I don't really care about it that much. I just care about having some limits so that I can keep this thing from breaking itself or its environment. Oh, Neil says the wrapper functions I was just describing sound a lot like CMSys. Yeah, they kind of are. It's, like a lot of vendors have their own thing that's kind of like that, where it's just, we can't trust those programmers to write directly to our hardware, so we better have them fill out some C structures, which we then copy into the registers. So I don't really get the logic behind it most of the time. Like, I really like writing abstractions that just completely go away after the compiler's done with them. So, I mean, a lot of this, just so much of microcontroller development is just like managing this giant mess that the vendors leave you and then expect you to build your application around, and then deciding like, well, okay, how much of this mess am I going to put up with versus how much of it am I going to try to clean up? And so I'm still kind of doing that with this project. There are some aspirational goals, like I can imagine having a really nice system where I don't write this in C at all. I write it in like Rust, and there's this Rust networking stack that seems like a really good match to this project called Small TCP. It's designed for no memory allocation and real time, and I feel like that's pretty much what I would want. But I think in the interest of expediency, I don't want to have to deal with both a language and like basically that would involve like everything I do being just pretty new for me and in general. And so I think that would just involve a lot of fighting against the technology versus using something that I know already would be pretty easy to get working. So I'm trying to find the right point on that spectrum for this project. And I think writing something using mostly open source tools, but also dealing with some of TI's libraries might be the right point on that spectrum to get something working, but then also not lock myself too deeply into any vendor tools. Yeah, Mitchell says small TCP looks really amazing for a project like this. And then, yeah, Lavender has a link in the chat. And yeah, it looks pretty much perfect for this project. It's just I don't know if I can handle the development and learning curve of doing something that's so new for this project right now. So maybe that's something where later on, maybe I can spend some time rewriting the firmware in that, since I don't expect the firmware for these would be very complicated. It's basically just going to be a really simple motor control feedback loop on the winch bots, and then some timers and some serial on the flyer, and then a thing that just accepts commands over UDP and then sends responses over UDP, probably. Very simple. Okay, let's see what the serial looks like and see where the problem is on whose end of this contraption. I need my thingy. And in fact, so White Quirk, who's the author of Small TCP, they're also using this exact same development board. So I might be able to borrow some of their code later to make this work. But right now, there's just so much like boilerplate work that I'd probably still end up having to do to get that working. USB cable. There's never enough USB cables. course, what this side of the shop needed was more USB cables. Oh, Neil says LWIP is pretty straightforward for UDP if you don't use the BSD abstraction. I think you and I are on the same page. That's probably where I was about to go. I haven't spent a ton of time going through the LWIP code, but from what I've seen so far, I think that's what I was going to look into next. I saw the header files for that, and it seemed like... Because yeah, they provide like a BSD socket abstraction, and just in general, I get a little cautious about code that does memory allocation and could just kind of take an unbounded amount of time running in a system like this, but pretty much all of that lives on like the main loop thread, and if I do all the work that I really care about for motor control in interrupt routines that are at a higher priority than any of it, like LWIP's interrupt routines, then I think I'll do all right. And that doesn't help if I like exhaust memory, but that's part of what the watchdog timer can help me out with. I can just reset the whole thing if there's a problem. And that shouldn't be too bad. If I reset one of the winch bots, then it should just pick up right where it left off. Like there'd be a little hiccup in motion, but then it would just pick up on the next packet. If it resets and then just doesn't come back, then there'd be a timeout on the sending side that would just kill the whole system. And that's what would happen if you emergency stop and turn off one of the winch bots, then the whole system turns off. If something goes wrong on the flyer, then that's less of a concern. It just mostly means we can't talk to the gimbal momentarily, but that'll also just watchdog reset and then hopefully just come right back up with UDP packets right where it left off. All right. Do we have a ground? Oh, I could have soldered to all these ground. This board has some really convenient ground test points, actually. I should get a couple of those. I've got one of these, well, I don't anymore. When I was working on stuff for Senryo, I had a couple of these boards that were just totally decked out with, clock inputs and ground test points and power inputs and all that, but this is still pretty much stock. Just starting to add stuff to this board. So there's one there. Right there. And right here. That's probably enough for now. Well, maybe one on this other side of the board. This one. It's a good number of grounds for now. Tsuko flyer has use for many grounds. Oh yeah, so Vince is asking about small TCP being written in Rust and that being kind of new in an embedded system. That's actually one of the things that I'm kind of cautious about too. Like, it's definitely possible to do Rust on an embedded system, but it seems like it's new enough that a lot of things are still changing, and I'm kind of worried about... So I think if this project was something that I was planning on working on continuously for like the next year, then maybe I would just go ahead and write it in Rust and have it evolve with Rust's ecosystem. But what I'm probably going to do is just write a bunch of firmware now and then not touch it for a while, and then probably have to modify it a little while later on. And that sounds like it'll be a huge hassle if I start out with stuff that's in flux right now and then don't continue tracking it for the next many months. And I get the feeling that the Rust on microcontroller ecosystem is still really, really, really in flux. But that's just what I've been hearing. So if you know better, then I would strongly appreciate a correction. I also just don't even know Rust, so I'd love an excuse to learn it, but haven't spent the time yet, so that would just be a time investment that I would need to make. Oh, interesting. So I've been simulcasting on beam.pro, but apparently they renamed to Mixer, so I'm at mixer.com/scanlime, apparently. This is the first time hearing of it. I was probably going to, I don't know, I'm still unsure how much I like beam/mixer. I've been trying that out as a secondary channel, but I think I might move to Twitch Creative since I probably actually interact with that more. Oh, Gavorge, I think, says that that's a simple chair for such an advanced shop. Yeah, I guess I don't have a super complicated chair. I mean, I have like more like a rolly office chair kind of thing for my desk over there, but I don't like using that when I'm filming because it creaks and makes noises. These chairs are really simple and they don't make noise, which I like when I have the microphone going. And Mitchell Johnson says, I'm really excited for the future of Rust and micros, but the Rust embedded GitHub group RFCs definitely support it being in rapid flux. All right. So maybe that's a thing to do for the future. Write something quick and dirty in C or C++ right now, but then make something later in Rust as a learning exercise. That would make a fun stream. Okay, I'll put a few things on the logic analyzer. Let's do reset, TX, RX, and then maybe also the JTAG clock, just so we can watch it program. And in some previous streams, we were having a lot of fun using this hardware with SIGROC and PulseView, so we might do some of that too. I might start out in the Cellier software, just since that's probably slightly more handy just for grabbing a simple trace, but I don't know. I think either one would work pretty well right now. Oh, that's nice. Neil has some C++ wrappers for the LWIP stuff that seem really that are really lightweight. That sounds really nice. I'm all for well-designed embedded C++ code. I don't think we need a lot of mega samples here. So we have reset, then TXD, RXD. This is TCK. Let's just try resetting this and watching the serial speed as it resets. Nothing? Oh, there it is. So I'm expecting 115, 200. Okay, that's saying enter text, which is what we're supposed to see and not what I was getting. So maybe the problem here is like a macOS serial port driver issue. Let's try using a Linux VM just to get a different driver's opinion about this serial device. I can't attach just the serial port to the VM, so I'll have to do the flashing in the VM too. Ah, no minicom. Oh, is this doing an automatic update in the background? Don't know. Usually there's like a unintended install or something like that. Oh, maybe it finished already. Good old rainbow cursor. Come on, get her. Are you ever gonna load? I just wanted to grab this link. And you need to recycle this instance of getter. Yep. Yeah, this seems about right. I mean, I don't know if I want to... I mean, it just doesn't seem like that much different from what I usually do, but I'm sure there are a lot of advantages to the new language. I mean, it seems like it's mostly just an abstraction around the nested vectored interrupt controller. All of their tasks, I think, are just mapped to like software interrupts. That's interesting. I kind of wanted to put that on the command line so I could tab complete it. Oh, that's a better sign. Okay, so maybe the serial port just does not work with macOS's drivers. That would explain a lot of the problems. So, how much of this can I do just from Linux? I think I just need to copy the repos I was working on into here. The shared folders probably aren't going to work, are they? Yeah, I pretty much never have any luck with shared folders with recent Linux guests. I don't think they've been maintaining those drivers very well. You liking that rack, Tuco? He is so chill. Let's also grab, what was that even called? LM4 tools, I think. Oh, I actually want some other stuff too. I want WinchBot firmware and LM4 tools. Alright, Ubuntu. There's our serial port. And we just need to build the flasher tool and run the flasher in here. So, WinchBot. Right now I'm just trying to run their examples, which you'd think would be straightforward, but I think I was having some kind of OS-specific problem with the serial port driver. Yeah, so let's use that. Let's also have another terminal and compile those flasher tools. Oh, I already had been in my path. Oh. This VM, I guess I didn't have a lot in it yet. Lavender says, is there a countdown to when the Rust community runs out of metals to name their libraries after? I mean, you can keep making up new alloy names, I guess. They don't have to be structurally interesting if you're just naming things. That's better. It'd help if I had the right name in there. Ah, and let's give it permission. Maybe we can just give this direct access to that Ethernet adapter too. Alright, waiting for IP, waiting for link, waiting for IP address. Cool. So just for running this example, maybe I can just give this a DHCP server. Whatever happened to like ETH0? Now we have ENS33 and ENX, all of those hex digits. Great. How easy is it to set up the DHCP server? I have a feeling I'm going to need to copy the name of this interface down. Okay, we can just use this default because I'm not using this anywhere else. I don't know, I kind of want something that's a little bit simpler. Let's see, for robots, let's just use 10.33.0.10. I should also give that IP address manual address. Isn't there a different way to configure things statically? I guess I could do this through Network Manager. Network Manager. Am I missing? Oh, there's Network Manager. It was up here. Which of these is which? Like, I know what device node these are, but they don't tell me what device these are. Nice job. MAC address is the one that starts with 70. This one. Don't have a manual address. I thought that's what I just set. I just set that. What if I replug this? Still no address. What gives, Network Manager? I don't know if that has any effect. See, man, I have the feeling that doing this through Etsy network interfaces is not the right thing when Network Manager is using this. Do I have... oh, I do have NMCLI. Connections... why does that not say there's a device now? Oh, unavailable. What does that mean? Maybe it realizes there's a DHCP server running on it, and so it's stepped back. There isn't a way to have the DHCP server set my address, is there? Maybe I do just put this in Etsy network interfaces. I just thought there might have been a reason that would be a conflict. Okay, I guess I'll do that. The other options I want. Static. And that's all. I'm just going to try replugging it and see if it does that automatically now. That looks better. And can we hand out IPs now? Just reset this board. That cat has quite a cape. Is this running? Oh, is the DHCP server not running? I know I started it. Oh, Etsy default. Thanks. Oh, I guess I just need to comment that. Great. I think that's fine. Can we reset this and get a lease now? I don't know quite how I'm going to want to do configuration eventually. I mean, it'd be easy just to burn different IP addresses into all the winch bots, just in the firmware, just by giving them different firmwares, but maybe there's some other configuration I could use. Oh, that took a while, but it got an address. Interesting. Now we just have to wait for Firefox to open. So that's coming off the microcontroller. And this has a few files coming out of a little on-flash file system that's just compiled into the firmware. They also have some URLs that have handlers attached, so you can turn an LED on and off. Let's get that on the screen. So the LED on the left, I think, is always on. Then the one next to it is activity. So I think those are Lincoln activity. Then the one on the right is blinking, and you can set the speed here. Now it's slower. I can set it to 100%, and it'll be all flickery. And then the LED next to the flashing one, I can just toggle. So that's their example. So, I mean, I may or may not include any sort of HTTP or TCP in here. It seems like I could, and it wouldn't really matter. Like, it would just be maybe some convenience, maybe some attack surface, but either way, it doesn't seem to matter so much for a project like this. I think mostly I want this processing probably UDP packets that include, well, in the WinchBot's case, the UDP packets would include probably limits for each of like velocity and torque and acceleration, and then it would let the motor operate within those limits, and then it would report back periodically. And then so the reporting back, that might be controlled by some other part of those packets that you send to the WinchBot. So maybe you tell the WinchBot, okay, apply these settings, and then also, by the way, here's my IP address so that you know where to report back the status. Something like that. Oh, that's a good idea. Mitchell Johnson suggests using a unique ID from the microcontroller to set the IP address using like a hash function. Yeah. I mean, they definitely have a way of like picking a unique MAC address based on a built-in hash, I think. Yeah. That would work if you, I mean, I think it depends on what layer I'm doing this at. I don't even know if I care about TCP/IP at this point. So this goes back to the larger problem of figuring out like how much complexity to bite off, how much to rely on existing but very complex libraries versus going for something lower level but intrinsically simpler and more reliable. It is tempting to just send out raw Ethernet frames and I mean, then I would have to know the... Like, it seems useful to have IP addresses that represent some kind of role in my network. So maybe I say that, like, the winch bots have these IPs. I mean, otherwise I just have to, like, have a table of MAC addresses in my source end somewhere, or to just do everything via discovery, which could also work. Just broadcast and be like, hey, I'm looking for the winch in this corner. Where are you? It's basically like application-specific ARP. I wonder what the options are like for sending raw Ethernet frames from, say, Python, since that's probably what I would want to use to control this. So the controller for this could be written in pretty much anything. It'll be running on a desktop computer. It'll probably be running on Windows because that's what I'm using for streaming. But, you know, most things are portable to Windows if you try hard enough. No, that's not. WinPCAP. Anyway, like, this is definitely something that I might want to avoid. So using, if I do everything with UDP and also implement ARP, then I don't have to worry about sending raw Ethernet frames on the application side, which might make portability easier. Yeah, WinSock. I mean, if I can get access to the raw Ethernet frames, I'm liking this kind of application-specific ARP idea where you just say, like, where's the winch? And then you'd be like, here's my IP, or here's my MAC address. And that would also be kind of nice because then you could just say, hey, where are all the winches? And then, I don't know, you could probably have some tool that, like, you run it and then it just detects all the winches that are plugged in, and if it doesn't care which one's which, like it's a firmware update tool or something, it can just do it to all the winches. But if it needs to know which one's which, then maybe you have a table that's like, this corner goes with this MAC address, and you can register them somehow. This seems annoying. That's not gonna... Maybe this just works. Maybe I'm expecting this to be weird in Windows. Maybe it isn't so weird. So for receiving on a raw socket, are we just going to get everything? Can we tell it which protocols we care about? Because that might be something not to do, since I think that might be like basically running all of my packets on the streaming machine through PCAP all the time. Doesn't seem like something I want to bother the CPU with doing. So anyway, there are a lot of different levels of yak shaving I could get into. I could start with the ground up and start building my own implementation of ARP that works just the way I like it. Or I could just jump up to LWIP with UDP, which is, I think, what I'm leaning toward doing. And if I do that, I could hard code IP addresses, or I could have some other broadcast protocol. Let's maybe just poke through the... Well, we could look at LWIP documentation. There's also just a lot of example code here that, like some of, I don't know, there's a lot of different directions this could go in. MQTT? Why would I want MQTT for this? I don't know why I would want... Like, MQTT, I can understand that being, like... I'm not an expert in that, but the way I understand it, it's like mailboxes that you can send messages to. But everything I'm doing here is point-to-point and real-time. So... Like, I want something that is not very many levels above just hardware Ethernet frames. Like, the concessions here that I'm making are to make the software easier on the PC side. Okay, so they've provided a few different examples. This is the I/O example we were just running, which is a little bit complicated because of all the stuff they've added to it. Also, this is one of the pieces of code that's just like, TI, why the hell are you doing this? This is supposed to be example code that people are naturally going to want to build on. And then in the example code, they're saying, this is only for TI products, and you can't combine it with open source code. So it's like, I can look at this, but I can't use it. Anyway, it's not very interesting. This is like their layer of stuff that you can do that's based on... Like, these are the implementations of their server-side functions. And then... See, but like the main functions, like the boilerplate, you know, for something that requires so much code just to get started, you'd think that they would provide that code in a format that people could actually reuse legally. Device locator service, what is this? That seems a little sketchy, but maybe a little useful. Utils/locator. Is this like a UDP broadcast responder? I mean, I could do something like this. I don't think I would want to use this exact code, because this is just some stupid thing that TI came up with specific to their example boards, and it has their stupid license on it and everything. Anyway, that's just using LWIP. The thing that they provided that's actually kind of useful that's specific to LWIP is this little glue layer that's kind of like a driver. Where is that? That's part of LWIP. This is not quite what I was looking for. Oh, it's this one. Man, this also has that same license in it, which I don't know how. What is the legal definition of viral in quote marks? Like, what does that even mean? I could imagine people arguing both ways over that, which is not what I want in my code, you know. But all this actually is it's basically a glue layer between LWIP and their Ethernet hardware, but it would be a huge pain to recreate something like this. Like, if I was rewriting this, I wouldn't want to make that kind of effort investment on top of something that was already kind of both legally and architecturally so shaky. So if I had to do a lot of work for this project, I would want to make sure that that work was actually something that would be, you know, not quite so throwaway. So it's like, either I want to do something pretty minimal that leverages as much of this garbage as I can without it getting in the way, or I want to try to maybe just go all the way with like Rust and small TCP or something. This is why I've been putting off this stream. I just kind of hate everything. Like, the whole world of embedded software is just terrible because it's like all this stuff that's written by silicon vendors who just want to sell more of their chips and don't actually care about the software as an entity that might want to, like, survive in the future. So they just, like, everything here is unfavorable. And so if I wanted to ignore all the LWIP stuff, the other two things they provided in the examples, there's something based on UIP, which is another small stack, which seems even worse. It only has one buffer each for transmit and receive, which is neither especially compatible with this hardware nor really a good idea for a 100 base T Ethernet device. And with this one, TI has done an even worse job of separating the driver code from the example code. Like, literally, the example code itself just has a bunch of this copy pasta that you would have to duplicate in order to get UIP hooked up to the network adapter at all. And then, of course, it has their stupid license, so anything you do with this file is legally dubious. So that's just kind of a pit of snakes that I don't really want to jump into. I think pretty much all the other examples are based on LWIP. They just have this one token UIP example that's not a good starting point for anybody. Like, it's basically just a proof of concept, but... And then, I mean, you can also just avoid all of this and talk to the hardware more directly. That's what I did in this GDB Ethernet thing that you may have seen. This was something I did for a different project, but using the same board. And it was basically an Ethernet driver for this chip written on like a Python GDB plugin. But there's a small portion of this in the firmware that actually initializes the chip using the TI libraries, sets up DMA buffers. So this is actually the closest thing I have to like a completely minimal proof of concept to just get Ethernet frames in and out of this chip. And it's actually kind of tempting just to start just with this and then process the frames all myself, do ARP myself. But if I can't, like, if it's annoying to process raw Ethernet frames on Windows in Python, then it might be worth going up to UDP at least. And so if I'm dealing with UDP, I probably want to just use this LWIP stuff, which means linking with but not modifying these files, I think. And then recreating these files, basically, because I can't copy these. I don't want to use them as is, but I can just kind of recreate the parts I want from these files and then pull in, just like link with the code from down here. The whole thing is just demoralizing, though. I wonder if I could just have the DHCP server. Like if I am using DHCP, it could hand out leases and perhaps also keep track of those leases for talking to the nodes later, but that seems annoying. This also has support for auto IP, so just assigning IP addresses pseudo-randomly in that like 169 dot whatever subnet. DHCP server? I think you mean client. Yeah, I was just reading the comment about FreeRadius. I've never used FreeRadius, but I think I'm pretty happy with UDHCPD. But yeah, I mean, if I end up having to run this on Windows, then I need something that runs on Windows. And I mean, yeah, I might just like skip the DHCP and use manual IP addresses. Anyway, so what have I got so far? So I think I've already started on what I was just saying, where I take that GDB Ethernet thing that I already wrote, so like I wrote the files in this directory, but I'm pulling in the stuff from TI's SDK externally, so like I feel a bit happier about the stuff here, with the exception of this startup file, which is just copied. I don't know whether I need this startup file, but like I could rewrite this. This doesn't have anything really useful. See, why? This is just copy pasta that TI included in all of the examples. Like, why does each example need its own copy of the BSS fill code? That's just sloppy. Like, this fucking copy pasta. Like, this just makes me so mad. And there's the build results. And so the file I have so far, I think this is basically just my GDB Ethernet example. So these are my buffers. I have 8 of them. This is where I would start to decide whether I want to use LWIP and like hack this up to call into the TI LWIP driver thing, or whether to just process stuff like this. Let's try just running this. I think before I had stopped when I ran into problems with, I don't even have that tool chain. I think I stopped before because I ran into that serial problem that we just earlier in this stream determined was just a macOS bug. At least the tool chain's easy to get in Linux. Just reading John's comment about Energia using, having an Ethernet UDP implementation. I would be really surprised if it was anything just but more TI copy pasta. Might be hitting my rage limit for this soon. This just makes me so mad. I still have this running. What did I do with the serial port here? Okay, so I'm just printing something out when I get a packet. wingebot.bin. Let's use the correct command. That one was small. I guess that's right. I think I had a version of this that printed something out right when I started, but then I had some problems with the serial port. Let's add that back in so it's easier for me to see when this is running. We got UART, and then it crashes. Maybe this was a different problem then. This might be more like one of the interrupts we need for the UART is not enabled. What is that M? Yeah, it was starting to say main loop happening. Yeah, so it's just filling up this buffer, and then how many bytes is that? So, and then there's probably, it's like 24 bytes, including the /r's you can't see. 26. I'm assuming this is just filling up a buffer, but did I have Sublime Text in here? No. I don't have any of the cool software in here. So we're using this UART library here. We do have the master interrupt enable. This is the UART library. So it has this option for buffered or not buffered. I tried turning this on to see if it made any difference, and it's still broken even with that. It's broken slightly differently, but I think it's easier to debug without that buffer. Is it possible I have another interrupt that's coming in and then crashing? Should I try that loop with interrupts disabled, maybe? Oh, where's my VM? That's weird. Caps lock is off, but the light is on. Which could actually be a VM issue. Funny story, I once spent a long time trying to fix that. And it turns out there's no way to set the keyboard light state from macOS correctly. At least there wasn't. And I had this awful workaround, which was really awful, and eventually caused this really funny kernel panic. Okay, same thing. So this might be a good time to try actually attaching a debugger. I forget how you use OpenOCD with this thing. TI-ICDI. Do I have that? This will probably be too old. Oh, maybe this is in the stable already. All right. All right. Oh. Oh, what port is that on? Oh, 3333. Okay, is this gonna work? No. Sigh. Let's try that again. Okay, now it started at the reset ISR. That's fine. Can we continue to breakpoint? Yay. Cool. We are debugging. Took a while to get through that oscillator config. I wonder what that was about. Got a lot of other halts happening here. I wonder what that was about. Okay, UART standard IO config. Let's just step through that for fun. Oh, this is so slow. I don't know why I'm getting halted at... Oh, we're single-stepping instructions up here, and it's just each of the instruction single steps are slow, and then it takes a while to get through an entire line of C code. So, let's just exit that. So, here we go. Let's go inside the printf. Okay, so then we're going to do a vprintf, which we can skip. Oh, was that the whole thing? No. I thought I saw something come out over here. Maybe we just single-stepped over more than I meant to, though. Oh yeah, that must have been the whole thing. Interesting. Oh yeah, UART vprintf. So what was P? Oh, that was the format string. Okay, so it's got a vprintf that goes directly to UART. Let's try that again then. So can we reset? Oh, how do I reset this? Target, remote. Oh, no, monitor, reset. Maybe if I press reset? No. I think I made a mistake and I don't know how to recover. Oh. Was that what I wanted? No. Very no. Reattach. Oh, we're still in UART printf, so we didn't actually reset. Maybe OpenOCD is no longer successfully connected. That seems better. Interrupt default handler. How did we get here? Oh! Startup code copy pasta doesn't have a... I thought they were gonna... I didn't look super closely at the interrupt code. I thought they did something smart with like weak symbols, but I think they just have copy pasta for the interrupt vector table that we need to replace. This is the startup code. That's right. That's right, we need to point this at the UART interrupt handler, and it completely isn't. Ah, this table's terrible. Oh, I'm just gonna have to do a whole bunch of monotonous creating of tables. But yeah, I think we mostly just want to attach that there. Anyway, that explains all the unknowns. I think I just need to turn the crank on this. I need to write a bunch of really boring code for this. And ugh. So I don't care about those. What does this need? This just needs to call main. These are all from the linker script. It needs to do all this garbage. This is a bit weird. Like, why didn't they provide a driver lib API for that? And it's weird that they did this in assembly, but not this. Anyway. That's a little stack. This is also just, I just hate so much about code like this. Like, even the way this is all just like corporate copy pasta comments, like, we needed a comment this large for this structure. And it could have been like, put it in this section. The linker script tells it where it goes, but no, it's like the proper constructs, because like the person writing this probably didn't want to bother explaining what it actually did. Anyway, I'm just getting mad at this code. I should probably quit streaming. Maybe I'll take a brief look at Energia just to see if that's worth looking at, but I have a feeling it's going to be even worse. Is this something else completely different? I just want to browse the code. Is this a port of the Arduino Ethernet Shield library? Or is this literally the Arduino Ethernet Shield library? I think that might be the case. add code, not issues. Huh. Boo. I mean, it's possible that this is going to be like a lot more total ugliness, but less that I have to directly interact with. But I'm not super hopeful right now. This is like one of the parts I hate the most about projects, where it's just you're just kind of like bumping into all these constraints that shouldn't even exist, except somebody out there made just a really stupid decision. I mean, if I did want to just receive Ethernet frames myself, I just have to implement ARP. ARP is really simple, so that's not a big deal. Just have to implement ARP and UDP, which it's not nothing, it's just more code, and like I would have to put it in some kind of module. It wouldn't be just small enough amount of code that it would hang out next to everything else I'm doing, so it would require actually writing a library effectively. Hardware LM4F libraries. Great. Servo, SPI, Ethernet. That looks like LWIP. I don't know. I mean, yeah, well, maybe I could use this. How hard is it to use the watchdog timer with Energia? Does it get in your way? Does it have a library for it? Does it not care? Is this like one of those things, like, I don't like using kind of Arduino type tools for stuff that I actually have reliability concerns with, because, I don't know, stuff like nobody cares about watchdog timers. Nobody cares about having no memory allocation. API reference. This is just Arduino. This isn't their API. Calling that as an API reference is disrespectful to API references. Alright. Well, maybe, I mean, I could use that, and then just... Like, if I use Energia, can I register my own interrupt handlers? That would be a question to answer. Neil is asking, do you want the project dump? I don't know what you're talking about, sorry. Oh. What? No. Is this only going to limit me to pins? Seriously? Do I just need to find Energia's interrupt vector table? Oh, is this a version of the startup code that doesn't have as bad a license attached? That might save me some time. This looks fine. That just looks like BSD with advertising. And this one's using weak functions. This is much better. So I can have interrupt-driven UART, which I'm probably going to want. Can I have interrupt-driven timer? Where do the timers go? So many of these are just pinned to the default handlers. Like, this is stuff where, like, you cannot use this functionality in the chip without modifying Energia. And that like, having any of those barriers built in just makes the platform kind of unusable at some point. Which is a shame, because, like, it'd be great if this was easy for people to get into, but then also still let you use everything in the chip. It doesn't require that much more, just attention to some details like being able to override all the ISRs. This is just making me mad, though. But at the very least, I can copy this since it has a more favorable license, so maybe I'll just do that. Neil says they have an LPC 1768 project with most of this done. How does that help? Everything exists in this form that is slightly not what I want, and that's what engineering is. I assume you're offering that because I would need a different dev board also. LPC 1768. What? Oh, does it have the phi built in and they're just missing magnetics? Yeah, this needs an external PHY still. Has everything else I'd need, I think. Yeah. That was kind of expensive. That's certainly less, but it doesn't seem to be sold anymore and doesn't have the Ethernet headers or maybe even the magnetics on it. I mean, this is fine, but it's more expensive and doesn't seem significantly better. So the thing that annoys me is not the lack of code that exists that does exactly what I want, because like that's fine. The thing that annoys me is all this stuff where people write code that is just not even useful because of the way they've encumbered it. Like, the code stuff, like that's fine, but like this licensing just pushes my buttons. Anyway, this code I can start with, it's fine. Oh, why is caps lock? Now caps lock is just stuck on no matter what I do to the button. That's interesting. Never had that failure mode before. Just have to poke it a bunch. I guess I also need to figure out whether this repository should be just for the winch bots, or whether it makes sense to have one repo for the winch bots and the flyer, and then just conditional compilation flags. Since, of course, the things they do are going to be kind of different, but the command processing behind both will be pretty much the same, I think. Oh geez, requires encrypted firmware loading? Yeah, no thanks. Is this just missing magnetics then? Do we have a price? Do we have information about breakout boards with Ethernet? This doesn't seem significantly better than what I've got. It just seems different. the... Like, this is a part of the project that is always super annoying, but I care about this a lot. Like, I really want the things that I build to have, like, a tool chain and a build system and a library set that they're based on that aren't going to leave me fucked later on, you know? And so having something open source, having something that actually, where somebody's actually thought about the licensing at least, that is important to me. Anyway, I'm just pissed off at this, so I think I should do something else for a bit. But I think mostly the next steps are just to write some boring code to glue stuff together and handle UDP frames coming in using LWIP. And it's fine, I just don't specifically want to do it on stream, because I'll just be cursing at it all the time. Oh, geez, I just noticed a $50 super chat from Chris in chat. That's amazing. Well, thank you so much. Sorry, I've been so dour about this part of the stream. Anyway, the thing is, like, I don't think this is actually bad. This is just, I have high standards for this part, and so I just always go through this process of trying to figure out, like, what is the least annoying way to do the firmware for a particular project, and then I'll make a foundation for it that I don't hate that much, and then afterwards it's usually fine. But, you know, like, I want something that stands as a foundation for other people, including my future self, to use for their projects, rather than just being something that is always going to be, you know, tied to, like, some random IDE that you have to download. No. Let's check out this this project in chat from Neil. Oh, I thought I saw a link. There's a link in the chat up there, but it isn't in this window. That is really strange. I thought we were only seeing errors with the IRC bridge, not with the app. If I reopen this, can I get the link back? Here we go. Thanks, caps lock. See, this is also stuff that I wouldn't really be able to build on because it doesn't have any, like, licensing attached to it. It's just, like, copyright. So, like, if I just found something like this online, I would ignore it. And, like, yeah, just have to rewrite that. It's fine. Project. Oh, okay. So apparently this is BSD license. Okay, well that's a thing. Yay. Yeah, I think I'll just write something. I think it'll probably just be basically the same layer of code that handles incoming and outgoing commands. And I think that'll probably be the same for all of the bots. So I'll probably just rename that winchbot firmware to be like TucoFlyer firmware or something like that. and then have build options for each robot. So the winches would just be built with, I am winch number 1, I am winch number 2, and they would just be built with static IP addresses. I think that's the simplest way to do this. Have the flyer built with a static IP, and then just have some common code that's built into all the micros to handle the UDP protocol, and then have, microcontroller specific code that would be different for the winch bots versus the flyer. That's probably fine. I don't know that I care to have a UDP-based firmware update protocol or anything like that. Since I don't want to write a bootloader for this, I might as well just run over to each robot with a USB cable and plug it into the ICDI chip. So I think that's fine. That's a good little cat. He's twitching like he's dreaming a little. Alright, well I think I might have to do some video editing to calm my nerves here, and then I think that I'll probably end up doing at least some of this firmware work off camera because it's so boring, or at least I can't get myself excited enough in it to feel like the stream is a positive experience, but let me know what you think. I mean, if you just want to sit there and watch me quietly / frustratedly poking at firmware, I can stream more of that. I can also just try to save the streams for some of the stuff that's more interesting. I also have some more CAD work to do on the flyer since I'm starting to get a picture of how that needs to work. I still need to figure out what the vertical supporting member is going to be. Maybe I'll shop for carbon fiber rods and see if something like that might work out. Anyway, thanks so much for stopping by. Super special thanks to everyone who pitched in the super chats in stream. That's been pretty amazing. And as always, a special thanks to everyone who pitches in monthly on Patreon, helping keep the lights on, keeping me in shop rent and cat food over here. So that's been super, super appreciative. Tuco has his eyes just slightly open, which looks really weird. Sometimes when he's sleeping like that, I'll come over and gently put my hand over his face to shield his eyes from the light. I think if I did it right now, I would just wake him up, though. Microhex says, who needs magnetics for an Ethernet or a PHY? Well, I've definitely done Ethernet like directly from like an FPGA pin kind of situation, but I wouldn't want that over any kind of long distance. I won't play the video in here because that would be, it feels like stealing someone else's video to play it on a stream, but maybe you could check it out in chat. Oh, half duplex Ethernet with just an AT-Tiny. Yeah, that could be interesting. I mean, there's a whole bunch of ways to get this done. I mean, I've used the ENC28J60 chip in the past, and you could certainly just take whatever microcontroller you want and shove something like that, or like one of the WizNet chips on it. That's basically the Arduino plus Ethernet Shield solution. But that's just, the costs add up, and, doing that with off-the-shelf Arduino parts ends up costing like probably $70 or something. And having one of those in all the winch bots just seems like a lot of unnecessary cost when I could just use a microcontroller that has those parts built in. And, I mean, as annoying as some of this stuff is because of the silicon vendors' particular ways of organizing their projects, I do like actually using the hardware more directly instead of just like hiding that on top of even more kind of shaky foundations. I mean, the Energia stuff, like it seemed like it was almost worth it to use their particular shaky foundation instead of writing my own thing, but the fact that I can't override arbitrary interrupt handlers, I think, kind of kills that. So, gotta go down a level. Anyway, I think the stream is wrapping up, but I will be back to editing, trying to get out another episode of the gimbal video, and yeah, be streaming again soon. I'm not exactly sure when, because I still don't really have a schedule for these things, but if you want to be notified as soon as the streams happen, there's a Twitter account for it, @scanlime live. There's a Gitter chat that you could hang out in, and there's, of course, the standard YouTube notification feature. Yeah, MicroMK says the ENC28J60 modules are quite cheap. Yeah, they are. I mean, they didn't used to be, but I'm sure you can get them a lot cheaper now. I had a project a while ago to do audio streaming over them, and it was alright. They're just so buggy. Like, if you look at the errata list for that chip, it's so big. And I don't know, I've written enough drivers for that chip for a lifetime, so I think it's time for me to move on. But if you have not yet had your fill of SPI Ethernet chips, then that's a fun one to play with. Hey, that was a cute little Yelp toque. Ow! Yeah, I mean, the funny thing is, like, if I was using an ENC28J60, well, I would still have to add some kind of microcontroller to that, and, well, I could make my some kind of microcontroller an Arduino or something like that, but then I would have all the same Arduino problems where if I want to use, like, a timer compare interrupt, then there's no way to set that up without hacking up the IDE. And I could use a different chip, like something that libopencm3 supports, which would be nice. But then I'm back into the territory of making a custom board or something instead of just using a $20 thing that I can buy on DigiKey pre-made. I think Tuco wants to play. We didn't quite get into messing with this thing on the stream, but it's still hanging out. That is our prototype so far of the mechanism for the winchbot. There's a lot about it that I might end up changing, but this is enough at least to try prototyping the firmware and to try to see if we can uncover any additional problems. You got a bolt, Tuke? Where is it, boy? I hope everyone has a good weekend. Anybody who has tomorrow off, hope you do something fun. You want this one to fly? No? All right, happy hacking, everyone. I will see you next time.